Welcome back to our third lecture. Today we are going to add another layer of our ROI analysis, which is the carbon pricing. We will see how putting a monetary value on CO2 reductions can completely change the financial picture of a project. By the end of this lecture, you will be able to calculate the carbon revenue, integrate it into your financial models, and run sensitivity analysis for different carbon prices. Well, here's the plan. First, we will understand how carbon markets work and the different pricing mechanisms. Next, we will quantify CO2 reductions in dollar terms. We will learn to integrate carbon revenue into ROI models, test different price scenarios, and finally apply it all in a renewable energy case study. So, this is where sustainability meets financial opportunities. Carbon pricing is simply assigning a dollar value to every ton of CO2 emitted. There are two main ways to do this: through a carbon tax or through an emissions trading system, sometimes called a cap and trade scheme. The goal is to encourage reductions in emissions and generate funding for low carbon projects. And it's not just for big industries anymore. We are seeing it applied in utilities and even in building projects. We have two types of markets: the compliance markets, which are legally regulated, like the EU emissions trading system, and voluntary markets, where organizations buy credits to offset their emissions, such as Amazon, Facebook, and Google. One carbon credit equals 1 metric ton of CO2 either avoided or removed. The price per credit can vary hugely, from under $5 to over $100, depending on the quality, demand, and certification standards. Valuing a carbon credit is straightforward. Take the CO2 avoided per year and multiply it by the market price. For example, if you avoid 500 tons annually and the price is $25 a ton, that's $12,500 in extra revenue each year. High quality credits, like those certified by the gold standards, tend to fetch higher prices because they are trusted and verifiable. We usually measure avoided CO2 by multiplying electricity savings by the grid emission factor. This factor changes depending on the energy mix of your region. Coal-heavy grids always have higher factors. Renewable heavy grids have lower ones. Example, a 120,000 kilowatt per hour saved times multiply it by 0.45 kilograms of CO2 per kilowatt hour gives 54,000 kilograms or 54 metric tons avoided annually. So these numbers are very important to be declared from a trusted organization in order for corporates to declare their carbon mitigation measures. The process is simple to integrate carbon pricing into the ROI. So step number one, you need to calculate the annual CO2 reduction. Step number two, you multiply it by the carbon pricing to get annual carbon revenue. Step number three, Add this carbon revenue to your energy and OPEX saving. Step 4. Rerun your payback, the net present value, and the IRR calculations with the updated savings figure. This can noticeably shorten your payback period and improve returns. Let's take an example. A PV system produces 175,200 kilowatt annually with an emission factor of 0.45. That's 78.84 tons of CO2 avoided per year. At $20 per ton, that's an extra 1,576.80 in revenue every year on top of your energy savings. This added income then flows into your ROI calculations. Carbon markets can be volatile. So we test multiple price points: $10, $25, $50, $75 per ton. Then we see how each one changes our NPV and payback. This helps us understand both the upside potential and the downside risk. Carbon revenue can be combined with grants, tax credits, and feed-in tariffs, which is FET, to make projects even more attractive. The more layers of financial benefits you stack, the faster your payback gets. Just remember, if you sell the credits, you can't also claim the same reductions for your own carbon footprints. That's called double counting. And for RECs, they have a specific ID number that's monitored by the issuing organization, and it is nearly impossible to issue it twice. When building this in Excel, your inputs are CO2 reduction per year, carbon price, and project life. Your calculations: annual and cumulative carbon revenue. Your integration: add this revenue to your existing cash flows. And your outputs: updated payback, NPV, and IRR. Let's move to this case study, and let's use our area LED retrofit example that we have used in lecture 2 as a case study. The capex is 50,000 energy saving, 120,000 of kilowatt per hour per year, with a 0.45 emission factor. That's a 54 tons avoided annually. At $30 per ton, we will get $1,620 in carbon revenue each year. We add that to our energy savings, and the payback period shortens immediately. Charts are great here. We can show how NPV changes at different carbon prices and highlight break-even points. Data tables are also handy for running quick sensitivity scenarios. But remember, carbon prices can swing dramatically, and policies can change. Verification and certification costs will eat into your revenue, and there's a reputational risk if your credits are seen as low quality or questionable. Use conservative price estimates for your base case. Always rely on certified emission factors and recognized credit standards. Update your model regularly with the latest carbon market data, and think about long-term policy and market trends. These can make or break your revenue potential. So here's your task. Model a 200 kilowatt peak PV system with 350,000 kilowatt hour annual output, an emission factor of 0.42, and a carbon price of $40 per ton. Include a degradation factor and run sensitivity for prices between $20 and $80. This will test your ability to integrate carbon revenue into a full ROI model. So before we end up this lecture, please take these takeaways. Carbon pricing can transform a project's ROI. So the math is straightforward, but accuracy in your inputs is everything. Always run sensitivity analysis to prepare for price swings and combine carbon revenue with other incentives to maximize returns. That's the end. Thank you very much. This is Dr. Zaidat speaking, and wish you all the best in your endeavors. Thank you, and see you later in lecture number 4.